The National Aeronautics and Space Administration has scheduled the second operational flight for September with Atlas-Centaur 7, Surveyor 2.
Surveyor's protective womb opened. Atlas burned out and fell behind. Centaur took over, hurtling the spacecraft on its way. Then, Surveyor came alive in space. Centaur, its job done, was cut adrift. Surveyor was alone, free for its long journey to the moon. The solar panel erected, and small nitrogen jets oriented Surveyor so that its sun sensor intercepted and locked onto its rays 24 minutes after launch, 1,000 miles out, racing onward at 22,000 miles an hour. The sun lock-on provided 1 point for navigational reference. 1 more point was needed to hold the spacecraft in a fixed and known attitude in space. Surveyor sought this reference by rotating slowly until Canopus, a bright southern hemisphere star, entered the field of view of its star tracker. Surveyor made 1 more revolution, mapping all stars in the sensor's field of view. As it saw Canopus for the second time, it was locked to the star by ground command. By this time, 36,000 miles had been logged in a little more than 4 hours of flight. Thereafter, Surveyor coasted for several hours, slowed by Earth's gravitational pull to 4,000 miles an hour, held in precise space attitude by its invisible moorings to the sun and Canopus. Surveyor 3 was launched in its 65-hour flight to the moon.
Surveyor began its descent to the lunar surface 53 hours after liftoff from Cape Kennedy.
140 feet per second in speed, 300 feet, 40 feet, 15 feet per second speed, touchdown, and the signal level is steady.
Because its radar altimeter and Doppler velocity sensor lost lock, Surveyor 3's vernier engines did not cut off, and the spacecraft made 3 soft landings before coming to rest about halfway down the side of a crater 650 feet in diameter and 50 feet deep.
We have a picture of some portion of the spacecraft. It is looking, the camera is so arranged as to be looking back into the spacecraft structure.
Shown here being tested before flight is Surveyor's surface sampling device. Upon a signal from Earth, an arm on Surveyor 3 with a small shovel attached extended out to this unknown soil.
A 5-foot-long arm with a hand-sized scoop. This device was designed to dig into the soil to determine bearing strength and other characteristics. It dug several trenches in the lunar crust.
Retrieved a scoopful and placed it on one of the spacecraft's landing pads. Surveyor's camera then took a look at the moon material in color. Color helps geologists tell the difference between various rock types and aids in determining the weathering process.
In other tests, the scoop was deliberately dropped on the surface, and pictures taken of the resulting dents and cracks. At one point, Surveyor's cameras interrupted their look at the moon to record this event, an eclipse of the sun by the Earth.
While the Earth was partially illuminated by the sun, Surveyor gave us a look at our own planet. Here, the continents and oceans have been superimposed for reference.
Surveyor 3 returned over 6,000 photos, including this one, showing several features recognizable in lunar orbiter photos of the same area.
Dr. Eugene Shoemaker answering questions about the flight and moon landing of Surveyor 3 and what it will be like when men walk there.
I think as far as walking is concerned, it's clear that a man's going to leave footprints, and there'll be a very accurate record of footprints, perhaps an inch or so deep, of just where he's gone. All he has to do is take a picture looking back, and he'll have a complete record of his traveling.
The 5th Surveyor spacecraft, SC-5, was delivered to Cape Kennedy in June 1967. This was the first spacecraft to be equipped with the alpha scattering instrument, designed to determine the relative proportion of various chemical elements in the lunar soil. Several particle detectors are strategically located under the hood of the instrument. The sensor head of the device also contained instruments designed to detect protons produced in the sample by the alpha particles. In addition to the alpha scattering unit, SC-5 carried a magnet assembly. Mounted on footpad number 2, it consisted of 2 bars, one magnetic, the other non-magnetic. By observing with the TV camera the extent to which material adheres to the 2 bars, it is possible to determine the presence and nature of magnetic material in the soil. In early September, SC-5 was transported to the launch pad. Liftoff occurred on September 8th. The launch was extremely accurate. So accurate that even without mid-course correction, Surveyor 5 would have landed only 26 miles from its planned target area in the Sea of Tranquility. To reduce this small error, Surveyor's vernier engines were fired for 14 seconds, about 18 hours after launch, to reduce landing velocity. Immediately after the firing, telemetry indicated that the compressed helium used to pressurize the vernier system was leaking through the regulator valve. A small particle had probably stuck in the valve seat. 3 vernier engine firings were commanded in an attempt to get the regulator valve reseated, but without success. Emergency tests at Edwards Air Force Base and at the Hughes facility in Placerita Canyon were run to determine minimum helium pressure and propellant requirements for an emergency soft landing. The plan, while ample helium pressure was still available, reduced the spacecraft's weight by burning all excess vernier engine fuel. The fuel could not be used later during the terminal descent because of the loss of helium pressure. By lightening the spacecraft, the thrust needed in the vernier deceleration phase would be reduced. Next, reprogram the terminal descent so as to defer retrorocket firing to the last possible moment, thus minimizing the period during which the vernier engines would have to cancel lunar gravity. Development of a new terminal descent sequence normally takes 4 to 6 weeks. For Surveyor 5, it was accomplished in 40 hours, ending when the spacecraft touched down on the moon on September 10, approximately 18 miles northwest of its original target site in the Sea of Tranquility. The first lunar chemistry set is shown in this picture, ready to do its job of analyzing the composition of the lunar soil. At the Jet Propulsion Laboratory, work continued on the mosaic, showing details of each of the Surveyor landing sites. In all, Surveyor 5 sent more than 18,000 pictures during the first lunar day and transmitted a total of 86 hours of alpha scattering data. Perhaps the most eagerly awaited of the Surveyor 5 results were those from the alpha scattering instrument, which provided the first direct measurements of the chemical composition of an extraterrestrial body. Payload for SC6 was similar to that of SC5. In addition to the television camera, it included the alpha scattering instrument designed to determine the relative proportion of various chemical elements in the lunar soil, and the magnetic and non-magnetic bars designed to determine the presence of magnetic material in the lunar soil. On November 6th, the spacecraft was launched in its 65-hour flight to the moon. Following liftoff, the flight of Surveyor 6 went precisely as scheduled. The selected touchdown area was in the region called Sinus Medii, in the heart of the potential Apollo landing zone. Flawless execution of the terminal event sequence placed Surveyor 6 on the lunar surface at a point estimated to be 6 kilometers west of the post-mid-course aiming point. The horizon is formed by a low ridge extending northeast across the moon's central bay. This ridge is one of a family of lunar mare ridges. Surveyor 6 continued to operate in a flawless manner on the lunar surface. Another lunar first was chalked up when the Surveyor 6's vernier engines were fired, causing the spacecraft to execute a programmed lateral maneuver in a westerly direction, a hop of approximately 8 feet. This 150-pound thrust raised the spacecraft approximately 10 feet off the lunar surface. Later photographs showed clear details of the original lunar imprints. Also, before and after the translation, readings from the magnet test were obtained, confirming the results from Surveyor 5. In sum, Surveyor 6 results were impressive. More than 30,000 high-quality photographs, 30.6 hours of alpha scattering data, additional magnet experiment data, and further solar corona photography. Plus, of course, the first planned liftoff from the lunar surface.
This rectangle extending across the face of the moon represents the Apollo landing zone where American astronauts will one day land. 4 surveyors have touched down in this zone. With the selection of potential manned landing sites completed, the last Surveyor mission, Surveyor 7, was purely scientific.
The area chosen was in the southern highlands near the crater Tycho. The spacecraft included the most complete scientific payload yet flown on Surveyor. In addition to the television camera included on all flights, SC-7 had the surface sampler first carried on SC-3. It also had the alpha scattering instrument to determine the proportion of chemical elements in the lunar material. For the first time, Surveyor was equipped to analyze lunar subsurface material. The spacecraft also carried a magnet assembly to determine the presence and nature of magnetic materials. SC-7 was also equipped with a set of small mirrors to determine the adherence of the lunar surface material, and larger mirrors to augment the area viewable with the TV camera and provide stereoscopic viewing. On January 6, 1968, SC-7 was launched by the Atlas-Centaur combination that had performed in the 6 preceding Surveyor missions.
This is the moon as Surveyor 7 saw it.
This picture shows Surveyor 7's leg resting against an 8-inch rock.
About 700 individual television pictures went into the making of this lunar landscape mosaic. Pictures of striking detail and revealing quality.
The area in which the spacecraft landed was by far the rockiest encountered by any of the Surveyor spacecraft.
Of particular interest to scientists was the debris excavated from deep beneath the moon's surface when Tycho was formed. It provided a different kind of sample for comparison with surface material previously studied.
On January 12, the surface sampler conducted the first digging operation on the moon since Surveyor 3 dug 4 trenches in April 1967.
Surveyor 7's mechanical shovel was put to work digging trenches 30 inches long and 7 inches deep. Rocks were broken and the strength of lunar material tested.
This 6-inch rock was just outside the 5-foot reach of the surface sampler. The grooves at the end of its reach were made by rivets in the blade of the scoop. Here's another view of the sampler digging in the lunar soil. It was taken by means of the 3.5-inch wide mirror on the Surveyor's mast. The mirror allows stereoscopic photos to be taken that can be used for accurate range determinations. To the right of the mirror is a pile of rocks a few feet from the Surveyor. The largest is about a foot across. The surface sampler had earlier been used to free the alpha scattering instrument, which had not completely deployed, and seat it properly on the lunar surface.
The moon-based Surveyor also turned its attention to our planet as it viewed Earth phases similar to those we see of the moon. The primary purpose of this experiment was to study the optical properties of the Earth, checking how it varied from phase to phase. The Surveyors accomplished their missions. They have helped locate landing sites for Apollo astronauts, and the significant scientific findings still being studied are providing a firm foundation for future lunar exploration. Reflecting on Surveyor's contributions, Dr. William Pickering, Director, NASA's Jet Propulsion Laboratory.
Surveyor accomplished everything that we had hoped for from that mission. 5 out of the 7 Surveyors which were launched landed successfully on the surface of the moon and operated on the surface. With the Surveyor photograph, we were able to show that landing a manned spacecraft on the moon is quite a reasonable undertaking, and in fact that the man will be able to walk on the surface of the moon without danger of falling through or sinking into the dust at any great depth. We were able to measure the bearing strength of the surface. We were able to get the general appearance of the surface, to point out that in certain areas of the moon, at least, there were not very many large rocks which have to be contended with, but there were, of course, numerous smaller and smaller craters. We also found the first chemical analysis of the surface of the moon by Professor Turkovich's experiment, and this showed that in the areas that we landed, the rocks, or the surface material rather, was very similar to a basalt here on the Earth. We were also able to dig in the surface and get an idea of the feel of the surface as we went down a little bit below the surface. For a matter of a few inches, the material is very much like a soft sand to dig in.